Okay, so this is an introduction to exercise 13A and 13B together. We are going through those together. It's introduction to the idea of exponentials and logarithms. We're going to start with the idea of exponentials and talk about, well, how do we solve them algebraically? So before we can do that, we actually need to understand the laws and how they work. Just in case you're not clear, exponential, index, same thing. So let's start by looking at our laws. In multiplication, we all know if it's a to the power m times a to the power n, gives us what? Did you guys do your index laws? Say a to the power of m plus n. Are we okay with that? Yeah? Sweet. Now what's the rule that has to be true before we can actually do this? Well, the base has to be the same, doesn't it? Right? The base has to be the same. Sweet. If we're multiplying them, we add the powers. Same thing with division. If we divide them, we end up with m minus n. Pretty straightforward. What happens if I've got something to the power of 0? Thank you. 1. Any value to the power of 0 is 1, assuming a is not 0. What if it's a negative power? Thank you very much. Equals to 1 over a to the power of x. So just in case you're not familiar with this rule, what you need to do is you bring that power to be a positive, and then you put it underneath a fraction, so it's a denominator. So 1 over a to the power of x. Okay? If, let's say, in a separate situation, you've got 1 over a to the power of negative x, same idea. I go 1 over a to the power of negative x, a positive x. Or I could just flip it on that fraction and write, a to the power of negative x. I get 1, sorry, give me one moment. There we go. Or I just get a to the power of x over 1. Basically, all I'm doing is I'm flipping it over the fraction, find the reciprocal. You guys remember the reciprocal term? Yeah? Okay. What happens if I've got a to the power of m to the power of n? Come on, be more vocal than that, guys. A to the power of mn. Thank you very much. What if I've got a times b in brackets to the power of m? Thank you very much. A, M, B, M. What about this one here? AX over BX. So everything inside those brackets have to the power of x. That's actually stuff that we already know. You guys remember how I said if I've got a fraction, I square the fraction, it's the top square divided by the bottom square, isn't it? Same thing, except this is in more general terms. This is when it gets a little bit more tricky. If I've got a to the power of 1 over n, what does that give me? What is a to the power of a half? A to the power half is the square root of a. Okay, anything to the power of half means square root. In this case, a to the power of 1 over n is just nth root of a. So you can see how the bottom number is the number here. The same thing applies here. Just in case you're not aware, square root is the same as running 2 root. There we go. Any questions about that? No? This next rule is pretty much the same thing, just a little bit of an extension. If I've got a to the power of, oops, sorry, my laptop's a bit laggy today. A to the power of mn, the number on the bottom becomes the root, thank you very much, the nth root of a to the power of m. Okay? So that's another rule that you guys have to go through. That is all the rules. Now, I know you guys have already done most of them, but hopefully you'll be able to apply them a bit better today. So those are the rules, and I'll keep those up on the screen later so that you can refer back to them. What I'm going to do, I'm going to go through some examples for us to go through together, just so we can simplify and apply these rules. In the first example, we've got x squared times 2 times x to the power of 4, times by 4. What do I do first? Collect like terms. What like terms do I have, Lucas? 2 and 4. So 2 times 4 times x squared times x to the power of 4. Sweet, Keely, what do I do from there? Yep, or I can collect the numbers first, right? So 2 times 4 gives me 8. And what do I get when I get the x squared times by the x to the power of 4? X to the power 6? Is that you saying that or Lucas saying that for you? X to the power 6, thank you. Okay, so all I do is collect like terms, multiply them, pretty straightforward. Alright, next one over here. I've got 3 terms. I've got 3x squared and y cubed. If I'm squaring every single one, what do I get? Megan, what do I have to do first?
Times the 3.
Say it again, sorry?
Well, you can start by breaking out the
You could start by doing this if you wanted to. I think there is an easier way than doing this because remember, this is one big term there. We're not adding. So what we have to do is you have to square every single term, every single value inside. So the first one we have is 3, because right now it's the same as saying 3 times x squared times y cubed squared. Would you guys agree it's the same thing? Yeah? And following with this rule, if I can scroll up, there we go. This rule right here, right now it's the power of m. I write to the power of m each letter in there. Everything I'm multiplying. Is that clear? Yeah. So I'm not adding anything. So it's all I have to do is I have to square every term. So in this case I get 3 squared. That's this one over here, 3 squared. Multiplied by x squared, which gives me x to the power of 4. Good. Times by y cubed squared is? Thank you. Y to the power of 6. Why is it not y to the power of 5? Good. Because it's y cubed to the power of 2. Or y cubed squared, not y cubed times y squared. Okay? So we end up with 9x to the power of 4, y to the power of 6. Any confusions about that? Riley, any questions? Okay. 2 more, and then let you guys get started with some practice. 3 to the power of x plus 1 times 3 to the power of 3x plus 2. Any ideas? Yeah.
Why isn't just the answer?
Say it again, sorry?
I think you want just the answer.
Will you tell me how you get there?
I just did the 3 times the 3.
3 times the 3.
So that'll be 9.
Okay.
And then the x plus the 3x, which is 4x, and then 1 plus 2.
So why are we 3 timesing 3 by 3?
Because it's 3x plus 1 times 3x plus 2.
Yep, so in the same idea, I've got a base of 3 and a power of x plus 1. Base of 3, power of x plus 1. My laptop is very laggy today. There we go. So if I go back to this rule over here, all I'm doing is I'm multiplying 2 terms, both of them with the same base, to the power. Okay? Actually, Zach, Mars, you guys paying attention? Thank you. So same thing, I keep my base, and I add the powers. Okay? So I go x plus 1 plus 3x plus 2. It's weird, right? Are we okay with that though? Are we stuck on how I get there? No? Okay. So from there, I keep the same base. I get 3, and I just simplify the powers. So x plus 1 plus 3x plus 2 gives me, Lucas, 4x plus 3, and that's it. I'm done. That's it. So I don't need to solve it. I just need to simplify it. Last one here is a little bit tricky. Any ideas how we do this one? Sorry? Zoom in, yep. There's 2 ways of doing this one. Yes, Mars?
You could do it the inside of the bracket first, or the inside bracket first, or the outside.
Good. You can either go from inside out, or you can go from outside in. Let's start by, I know, just from general experience, that let's go from outside in. It makes a little bit more sense. So, if I've got something to the power of -2 to the power of 3, would you agree that I can write the same thing as 1 over 3 to the power of -6? Same thing? Because all I've done is multiply the powers, right? Because it's to the power of. If I get something with a negative power, how do I change it to be a positive power? Sorry? Flip it? Yep, let's flip it. So I get 3 over 1 to the power of 6. Are we okay with that? I'm actually going to do it the long way and explain why we just flip it. So if I do this, what happens is I've got 1 over 3. If I'm writing to the negative power, to make it a positive power, I have to put 1 over whatever we've got a negative. So 1 over 1 over 3 to the power of 6. Are we okay with that? Yeah? It's the same rule as this one over here. To make it a positive power, I put it 1 over whatever it is. And then I just change to a positive power. From here, I get something like this. I'm going to go ahead and just expand it. It's equals to 1 over, what's 1 over 3 to the power of 6? How do we do that? What's 1 to the power of 6? 1. Does anyone know what 3 to the power of 6 is? Someone have a calculator ready. So that's, sorry? 729, thank you very much. I'm going to take your word for it. 729. Is this a viable answer to just leave it off as? No. How do we simplify it? So, what you can do is you can treat them as normal fractions and treat them as normal fractions and simplify from there. So, I've got equals to 1 divided by 1 over 729. Agreed? Yeah? Would you agree if I write 1 as 1 over 1? Yeah. If we're dividing fractions, what do I do to divide them? Say again?
So you keep the first one and change the divided sign to a times sign.
Thank you very much. I just do this. Hopefully you guys remember this from primary school. And we end up with, multiply them out, 729 on 1 or just 729. Okay. Any questions about that? Sweet. I'll leave this up on the screen for you guys to copy if you want to. I'm going to hand out some exercise 13A, 13B sheets so you can practice this. You do not have to complete the textbook questions for these two exercises. I understand it's not a reasonable amount of work to get done. However, the questions are up in there if you'd like to complete extra work.